Hello and welcome to today's Arduino tutorial. I'm Pranav Sukumaran and today we're going to talk about all the hardware parts of the Arduino that you're going to need to know about in order to complete your own projects. So first off, what is the Arduino? An Arduino is basically a small cheap computer that you can use in order to learn about electronics or prototype basic electronics projects. It doesn't cost that much money, which means that it's a really cheap and easy way to get into electronics. So first off, we're going to need to figure out how to power our Arduino. So the main two sources of power on the Arduino are the USB jack over here and the barrel jack over here. Now the USB jack is useful when you want to program your Arduino, because you can just plug the Arduino in to your laptop like so, and you'll notice that it's powered, and you can also program the Arduino with your laptop without needing a separate power source attached. Now, when you're not programming your Arduino, you might, or if it's in a if your Arduino project is mobile or it requires the Arduino to be away from a bulky computer, you might not want to have it plugged into a USB port. Instead, you can use a 9-volt battery attached to a barrel jack like this and plug it in here. And this will also supply power to the Arduino. As you can see, it's on. Next, let's talk about some of the pins on the Arduino. So the pins on the Arduino are basically how you're going to connect to external sensors or create circuits, which you're going to need to know how to do in order to complete some basic projects. So first off, let's talk about the power pins over here. The power pins are from left to right, the 3.3 volt pin or 3.3V here, 5 volt, which is 5V, the ground pins, which are designated by G and D, and the voltage input pin, which says V in. 3.3 volts and 5 volts, both the 3.3 volt and 5 volt pins both supply 3.3 volt and 5 volt power, as you can guess. This is constant power, and you can't change the value that each pin outputs, and you also can't control when the pins output. So these two pins will always be outputting 3.3 volts and 5 volts as long as the board is powered. You don't even need a program in order for these to be working, which is useful if you want to test some basic circuits without writing a whole program. These two pins, the ground pins, are used to complete circuits. And when we talk about circuits in a separate video, we'll cover what ground is, but know that you'll need these in order to complete any circuits. The voltage input pin is actually another way that you can power your Arduino. You can actually supply power through this pin. However, we're not going to be doing this in many of our projects, so we won't cover it here. Next, let's talk about the digital pins. The digital input-output pins are pins that, as you can guess, can either take a digital input or a digital output. So what is a digital input or output? A digital input or output, or let's just say a digital signal, is a signal that can either have one or another state. So basically, it only has two states. So let's say a switch only has two states. It's either on or off. It's something like that. With Morse code, it'll either be like dots or dashes. With bits, it's either 0 or 1. And in terms of the Arduino, the digital states are either high for high voltage or low for low voltage. High voltage generally means 5 volts, and low voltage actually just means 0 volts. So a digital input could be obviously a button, a switch, or some other kind of input that will only have one state. So when the input goes to 5 volts, the Arduino will register that input as high, and when the input is 0 volts or close to that, the Arduino will register that input as low. However, actually we should talk about digital outputs too. Digital outputs are similar, except instead of taking in values, you're actually just powering these. You're actually pushing voltage through these pins. So let's say that you want to power an LED. That the LED either has two states. It's either on or off. So if you want to power an LED, you'll probably wire the LED from one of these pins through a resistor through the LED and then back to a ground pin. And then in a program you can designate a certain pin, let's say pin 5, as an LED, as the pin you want to have a digital output on. And when you set this pin to high, it'll run a high voltage or 5 volts through the LED. Well, it'll run 5 volts through the circuit, which powers the circuit. And when you set the pin to low, it will not run voltage through the circuit, which will turn off the LED. So if you want to turn on and off parts of your project like LEDs or fans or stuff like that, you'll probably want to use these digital pins, which are numbered from 0 to 13 for a total of 14 digital pins. Now let's talk about the analog input pins. Now, unlike the digital pins, these can't be used for outputs. And the reason for this is because these pins they can basically measure the amount of voltage that is flowing through them from 0 to 5 volts. It's on a relative scale. It's not going to exactly tell you this signal is 0 volts, this signal is 5 volts, but it can tell you relatively based on a number scale from 0 to 1023. So if you plug something into here, and if you plug, like, let's say a light sensor into here, and the light sensor gives the analog input pin a voltage of 5 volts, you'll get a reading of 1023. And if it does a reading of 0 volts, you'll get a reading of 0 on the analog input pin. Now, if the light sensor gives a voltage of 2.5 volts, the analog input pin, which will probably give you a reading of around 512, which is really useful because unlike the digital inputs, you can actually, instead of figuring out whether or not there's light in the room, you can measure exactly how much light is in the room. This is also useful for ultrasonic sensors. Instead, you can measure not exactly, but you can measure generally how close or far an object is to your project with an ultrasonic sensor. And this would not be possible unless you could take in a range of values instead of just 0 or 1. And yeah, these are numbered from 0 to 5 for a total of 6 pins. Last but not least, we're going to talk about the reset button. The reset button is pretty simple. As you can assume, it just resets the board and it runs your program back again from the start. This is useful if let's say your program, if you're testing your program, you can use a reset button to test your program multiple times, which will speed up testing. Also, if your program requires, if your program takes in values at the very start, let's say you have a light sensor attached to your project, right? And at the very start of your program, the light sensor reads, the Arduino reads from the light sensor and uses that as an initial, as a variable at the start, some kind of baseline. Now, if the light sensor does not read correctly, you don't want to just unplug and replug, and if you don't want to unplug or replug your Arduino, you can just hit this reset button, and then the Arduino will automatically rerun the program right from the start, so it'll record a new value. So this is useful for either testing or whenever you need to reset your program. That's all for the Arduino hardware. In another video, we'll talk about the basics of the Arduino IDE and how a basic Arduino program is structured.